All right, so we have s squared minus s cubed is equal to 12. Okay, now let's move 12 to the left part of the equation. Okay, so we're going to have s squared minus s cubed minus 12 is equal to 0. Okay, so this is the same as s squared minus s cubed minus 8 minus 4 is equal to 0. Okay, so we have further simplified the 12 as minus 8 minus 4, or we have rewritten 12 as minus 8 minus 4. So minus 8 minus 4 gives us minus 12. Okay, so we are going to have s squared minus s cubed minus 8 can be written as 2 exponent 3. 2 exponent 3 minus 4 can be written as 2 exponent 2 equal to 0. Okay, so this is what you have. Now here we group the squares and then we group the cubes. Okay, so you're going to have s square minus 2 square minus s cube minus 2 cube equal to 0. Okay, this is what you have. Now we can rewrite this equation in another form. Okay, so we can introduce a bracket. We can have s squared minus 2 squared minus, we can introduce a bracket here and have s cube plus 2 cube equal to 0. Okay, so this is what we have. Okay, now this is difference of two squares and this is the sum of cubes. So we are going to apply their respective identities. Okay, now we know that if you have a squared minus b squared, this gives us a plus b, a minus b. Do you get me? Now if you're having a cube plus b cube, this gives us a plus b, and I have a squared minus ab plus b squared. Okay, so this is what you have. All right, now here we are going to put the values of the put in the values of the squares and the values of the cubes. Okay, so let's start from the square. So we are having a squared minus b squared. Do you get me? So we are going to apply this here. Okay, so you're going to have s plus 2, s minus 2. Okay, so we are here minus, okay, let's just introduce a huge bracket. Okay, let's introduce a bracket. Okay, so we are going to have, okay, we have the sum of the cubes here. So you're going to apply the sum of cubes identity, which is this. Okay, so you have x as a and 2 as b. Okay, so you're going to have x plus 2. Okay, and then have s squared minus 2x plus 2 squared, which is 4. Okay, equals 0. Okay, so after applying the identities, this is the equation we have. Okay, so you can see you have s plus 2 here and they have s plus 2 here. Okay, so we can apply factorization. Okay, since s plus 2 is common, so you bring s plus 2 here. Okay, s plus 2 is out. Now what you are left here is s minus 2, so you have s minus 2 minus, okay, minus s squared minus 2x plus 4 is equal to 0. Okay, so this is the equation. Okay, now here we can equate s plus 2 is equal to 0. Okay, so you can say case 1, we have s plus 2 is equal to 0. Let's call this equation 1. Okay, and then case 2, we have, okay, we have s minus 2 minus, okay, so let's write all all that is in a bracket. So you have x squared minus 2x plus 4 is equal to 0. Let's call this equation 2. Okay, so we have equation 1 and then equation 2. Okay, now from equation 1, okay, we can say x is equal to minus 2. Do you get me? So the first value of x that we get here is minus 2. Okay, let's call that x1. Okay, now we are calling this x1 because we are going to solve this quadratic equation here and then have two values of x and then call them s2 and s3 respectively. Now let's do s. So equation 2 is s minus 2 minus s squared, okay, minus 2x plus 4 is equal to 0. Okay, so this is equation 2. So let's break down the equation. So you're going to have x minus 2 minus s squared plus 2x minus 4 is equal to 0. Okay, so let's group the equation. Okay, we are going to have minus s squared plus 2x plus x minus 4 minus 2 is equal to 0. Okay, this is what you have. So you're going to have minus s squared plus 3x minus 6 is equal to 0. Okay, now let's rewrite the equation. Okay, or let's put the equation in another form. So you're going to have s squared minus 3x plus 6 is equal to 0. Okay, so this is our final equation. Now let's introduce the formula for the determinant and know what the solutions or what the final solution of the equation will be, or what the final values of x will be. Okay, so we can say v squared minus 4ac. Do you get me? So here we are going to have minus 3 squared minus 4. A is 1, c is 6. So you're going to have 9 minus 4, 6 is 24. Okay, so what you have is minus 15. Do you get me? Which is less than 0. Now, what this tells us is that we are going to have complex root, or we are going to have an equation with no resolution at the end of the day. Okay, now let's try that. All right, so let's continue. Okay, so from our final equation, okay, b is 3. Okay, it's minus 3. So you're going to have minus 3 plus or minus. Okay, so here is going to be minus 3 squared minus 4. A is 1 and c is 6 all over 2 by 1. Okay, so this is how it's going to be. So you're going to have x equal to 3 plus or minus 9 minus, okay, this gives us 24 all over 2. Okay, now let's solve the equation. Okay, now let's continue here. Okay, let me write it here. Okay, so we have x is equal to 3 plus or minus 9 minus 24. Okay, 9 minus 24 all over 2. Okay, so we are going to have x is equal to 3 plus or minus 9 minus 24 is minus 15. So you're going to have minus 1, 5 all over 2. Okay, so this gives us s is equal to 3 plus or minus root 15i. Okay, root 15i all over 2. Now we are introducing the I as an imaginary number because of the negative, or because of the minus which is attached to the 15, or because of minus 15. So at the end of the day, the final value for x that you have is this. Okay, Now, since we have already called the first part of x as x1, okay, we can break this down further. We can break this down further and have s2 being 3 plus or minus root 15i. Sorry, s2 being 3 plus root of 15i all over 2. Okay, so this is s2, and then have s3 as 3 minus root of 15i, okay, all over 2. Did you get me? So at the end of the day, we have we get three values of x, with the first value being -2, okay, and the final values being s2 and s3. Okay, so this brings us to the end.